What's up, Algebra Bros? It's Mr. C in here, and in this video I'm going to define what a complex number is, talk a little bit about the complex number system, and then show you that we can do some operations with complex numbers that are very similar to the operations that we can do with regular real numbers. Alright, so up right now is the definition of a complex number. A complex number is a number of the following format: a plus bi. Okay, and I want to note that I is the imaginary unit, which is equal to the square root of -1. There are a couple of parts to this. Of course, there's the part involving a, and then the part that involves the bi expression. When a complex number is written in this format, it's said to be written in standard form. And that number a represents the real part of the complex number, and then the number b represents the imaginary part of the complex number. So basically, a complex number is the most general form of a number that we have involving the imaginary unit, but it's also the most general form of a number that we can have when the number that we're working with is strictly a real number. I want to share something interesting with you. It turns out that every real number is a complex number. So for example, if we had the number -3, we could write that as -3 plus 0 copies of the imaginary unit I. If we had the number pi, we could write that as pi plus 0 copies of the imaginary unit I. So there would always be a way to rewrite a real number in this complex number format. But it doesn't work the other way around. Not every complex number is a real number. So with all of that said, let's imagine that we have this blob. And this blob contains the set of real numbers, which is often denoted by that bougie R. So numbers that would be part of the real number system would be numbers like -3 and pi. The complex numbers create the biggest number system that we work with in this course. And by biggest number system, I mean that it's bigger than the set of real numbers. In fact, the set of complex numbers contains the set of real numbers. So I'm going to draw another blob, this time green, and I'm going to denote it with a bougie C. So it's kind of like a blending of two sets where we have the set of real numbers that is completely contained in the set of complex numbers. Now, because the blue set is contained in the green set, any number that's in the blue set is also going to be in the green set. But there are some numbers in the green set that are not part of the blue set. So for example, the imaginary unit I, that's a complex number. It's the imaginary unit, but it's not a real number, in which case we call it non-real. We could have something like 11 minus 3i. That's a complex number, and we'll actually be working with that in just a moment. But it's not a real number because it contains a proper unit of the imaginary unit. So every real number is a complex number, but not vice versa. There are some complex numbers that are not going to be real, in which case we call them non-real. All right, so with all that said, we're going to do some operations with complex numbers. As it says in the box here, you can add, subtract, multiply, and divide complex numbers. So for example, we have the instructions here: write each expression in the standard form a plus bi. And in example part A, we're taking the complex number 11 minus 3i and adding it to the complex number -3 plus 5i. I want you to imagine how you would go about doing this if the i's were x's. Basically, it'd be like adding two polynomials together. What you would have to do is check for any numbers in front of the set of parentheses. In this case, there's nothing different than 1. And if there's a number different than 1 instead of in front of either of these set of parentheses, you would distribute it. So seeing that there are no numbers in front of the sets of parentheses here, we can quickly abandon them. Write 11 minus 3i plus -3 plus 5i. And what we're going to do is we're going to combine the real number parts of each of these complex numbers, which is 11 and -3. That's going to give us 8. And we're also going to add together the imaginary parts of each of the two numbers. So the -3 and the 5, or the -3i and the 5i, to give us positive 2i. And that's definitely in the format a plus bi, which means we're done. If we peek over at example part B, we're asked to subtract two complex numbers. And what you want to do here is distribute the minus sign to clear parentheses. Of course, nothing in front of the first set of parentheses, so you can unleash them. So we'll have 2 minus 3i minus 4 plus 9i. And much like in example part A, we can combine the real parts together. That would be 2 and -4 to get -2. And then we can also combine the imaginary parts together. That would be the -3i and the positive 9i to give us positive 6i. All right, in the next video, I'm going to show you how to multiply two complex numbers together. In the meantime, let me know if there's anything from this one I can clarify. Otherwise, I'll see you then. Thanks again for watching.